We are going to be taking a look at delegates and events. And first, we're going to look at custom delegates. There are two different types that we'll be looking at. And then we're also going to look at delegates that are built into the C# language. So custom delegates. Basically, a delegate is an object that holds a reference to one or more than one method signatures. And when we are working with different events, sometimes we need to pass a method as a parameter to other methods. And that is why delegates were created. And so basically, you can kind of think of a delegate as something that gives a name to a method signature. And the method signature is the first line of the method. Okay, so we're kind of giving a name to that signature so that we could, if we wanted to, pass that as a parameter. That's kind of the idea, and that's why they were created. There's two different types of delegates in C#. There are single cast delegates and multicast delegates. A single cast delegate points to a single method signature. A multicast delegate points to multiple methods. And so if you invoke or run a single cast delegate, it's going to execute one method. And if you invoke or run a multicast delegate, it is going to run several methods. So first, we're going to take a look at a single cast delegate. And there's basically 3 steps to defining and using these delegates. First, you have to declare them. And in declaring a delegate, you have to use the delegate keyword. So that would come before the return data type, because remember, a delegate gives a name to a method signature. Okay, so you'll use the word delegate before the return data type. And then after the word delegate, you would have your method signature, whatever that may be. So if there's a return data type, you'd have that in there. If you have parameters, you would have their data types in there as well. You can see that I do have a modifier here, public. And so that's kind of how you set them up. And then once you've declared it, you need to instantiate it. And that actually is going to require using the new keyword. And when you use the new keyword, you are getting a delegate object. So the syntax for this is you've got whatever you are calling your delegate, whatever you're going to call the delegate object, equals new, whatever you are calling your delegate. And then in parentheses, you are giving it the method that you are connecting this delegate object with. Now, the only hard and fast rule here is that you've created this delegate, okay? And if the delegate has no data being returned and no input parameters, then any method that you associate with it has to be set up the same way. It can't return data and it can't have input parameters if you have set up the delegate that way. So that's kind of the only thing you really need to watch out for. So in this little example, we do have the delegate, and it's called my delegate. You can see that is the method signature. And then I've got several different methods, and you'll notice that they all have kind of the same signature. They are not returning data, and they have no input parameters. Okay, so then when I instantiate the delegate objects, and remember, this is a single cast. Okay, so I have to have a separate delegate object for each of the methods that I want to associate with the delegate. So here I've got my delegate, which I'm using like a data type, giving that object a name equals new my delegate. And then this is the method I am associating with it. Okay, so it's in a class called my displays, and it is called display. Okay, and for this to work and not flag an error, this method has to have the same return data type and the same input parameters as the delegate, and it does. Okay, and you can see I'm creating a second and a third delegate object, and I'm setting them equal to the different methods in my displays. Okay, and then at this point, I've declared it. I've instantiated it, so I've created an object. And now I'm actually going to execute the method. So I'm going to invoke it. And to invoke it, all I really have to do is use my delegate object. And because it's not expecting any input data and it's not returning anything, it's just the object and then the parentheses. And each one of these is then going to run a separate method. So here is the whole entire program. Okay, from declaring the delegate up here to instantiating it. Instantiating creates the delegate object, and it associates that with the method it is going to execute. And then invoking those delegates actually executes the method that is associated with them. Okay, and if you want to see this run, we can go ahead and run it. You can copy and paste all of these examples into Visual Studio, and they all should run. So I'm just opening up my playground project here. And here it is. So you can see I just copied and pasted the code, and now I'm going to go ahead. We don't need these error messages, and I'm going to run it. Okay, so you can see that the delegates did run the three methods. Here's another little example. And this one does have input parameters, and it is returning data. Okay, so I wanted to show you what one looked like that was set up like this. So any method that you use is going to have to be set up the same way. So I've got addition and subtraction, and you can see that they are set up the same. Okay, the signatures match what I have for the delegate. Okay, so I've declared the delegate. I've got my methods that I want to associate with it. And then I'm going to instantiate. So this requires creating an object, a delegate object, and then associating that with the method I want to connect with it. Okay. So here I'm instantiating, and then here I am invoking. So I'm going to use this new method delegate that I'm calling C. So here I've got addition of 5 and 10 is, here is my delegate, and I am passing 5 and 10. And it will run the addition method and return the result here and display it. And then here I'm doing the same thing here with subtraction, calling it D. Subtraction of 5 and 10 is, and then you can see I've got D, which is my delegate for the subtraction method, and I'm passing it 5 and 10. So you can kind of look at a delegate like an alias. Okay, so um, it's going to go ahead and run that and pass it those values and display the result here. Okay, and this is another one you can copy and paste and run. And so here is another example. So we've looked at an example that has no parameters and doesn't return anything. We've looked at an example with input parameters and a return data type. And now this example is showing one input parameter and nothing being returned. Okay. This example is also a little bit different because we have a property that we're working with and we are in a numbers class. So we're going to be associating this delegate with the addition and multiplication methods in the number class. And you can see that they have the same method signatures. So here I've got numbers as my class, and it's a different class than the program. And this is probably one of the more confusing things about the delegates is that you do need to pay attention to where they are located and where the methods that you want to associate with them are located. And if they're in different classes, you do have to prefix them. So here I've got numbers.calc, okay, which is my delegate. Here's my object. And I'm setting that to new numbers.calc. And now I am associating the addition method with it. And I'm doing something similar for the multiplication method. And I've decided to use a random number to give me a starting value for this property. And that property is part of my numbers class. Okay, so I retrieve a starting number and I set it to numbers.num, which is that property. And then I retrieve another random value and I invoke the N1 delegate, which is associated with the addition method. So it's going to take that random number that I have stored in add, and it's going to run through the addition method, which is going to take the number and add in this random number. Okay, and this kind of displays what the starting number was, what the number we added was, and then what the new resulting property is going to be. Okay, and so then I take the current value in the num property. I put that into my starting value. I grab a new random number and I pass that to the N2 delegate, which is associated with the multiplication method. And then I'm writing out the starting value, the random number we're multiplying, and then the new version of the num property because that's getting changed. So let's take a look at this one and see how it runs. Okay, so the starting number was 52. The random number that I'm adding is 54. And so you can see that when it called add, it did in fact calculate the result as 106. Okay, then try to pull this up here. It took the 106 because every time we run through these methods, it is changing our num property. So when we added in the 54, num became 106. So we took that 106 value and made it our starting value. And then we went and retrieved another random number between 1 and 10. And then we passed that number to the multiply method, and we calculated a new value for num. Okay, so num ended up being 848. And again, you can kind of look at these delegates as aliases for the method signatures. Okay, so those are single cast delegates where we just have one delegate object and it invokes one method. You can create a multicast delegate, which is going to be more than one method. To add methods, you can use plus equal. To subtract, you can use minus equal. So you can add methods to the delegate and you can remove methods from the delegate. And as far as declaring the delegate, you're not really going to notice any difference between multi and single cast because they're declared the same way. Okay, it's when you are instantiating it that there is a difference because in a multi-cast, you are creating a delegate chain. You're adding multiple methods on. Okay, so you're going to initially start instantiating the same way, where you've got the name of your delegate, whatever you're going to call your object equals new name of your delegate, and then you've got your method name in parentheses. Okay, but after that is where it is different because you're going to add more than one method. So you're going to take your delegate object plus equal, and then the method that you're going to add. So I did do kind of a little code snippet here. And so I've got a class called Math Solutions. And there's three methods in that: get sum, get product, and get larger. And so I'm creating a class object because in order to get to the methods, I have to call them with a class object. And so for my delegate, to connect that delegate to the method in the class, I have to use the class object dot, and then the name of the method. Okay, so here's my delegate, and that connects one method. And then to add the other ones, I'm simply using my class object dot, and then the method name. Now, if I wanted to remove something from the chain, I can use minus equal, and then I would be removing the method using the object dot method name. Okay, so I can add them and I can remove them. Now to invoke the method, I would be using the delegate name, and in parentheses, I would be sending it the data that it is expecting. Okay, so here I'm invoking it with two hard-coded numbers. Here I'm invoking it with two random numbers, and it's going to work either way. So looking at the full program, I've got the delegate defined globally. So it is above the class. And you can see I'm not returning anything and I'm expecting two double values. And then in the class, I have three different methods that are set up with the same signature. Okay, so I've declared it. And then here is where I'm instantiating. Here's where I'm instantiating it. First, I have to create a class object. Class object is necessary to access the methods. Okay, and then when I instantiate, I create the delegate object and I bind it to the different methods. So I create the delegate object, okay, and bind it to the first method. And then I add in the second and the third method. Okay, so if we look up here, I'm calling it math delegate. So I use that just like the data type. The same way you use the class name, kind of as your data type. Okay, so I'm using the delegate name. I create a delegate object. This is equal to new. Here's the name of my delegate. And then here is the method I'm going to bind. Okay, and so here is invoking that delegate the first time. Here is invoking it with random numbers. And then here I am removing one of the methods and I'm invoking it. So it's only going to run get sum and get larger. And that's because for this last one, I removed get product. Okay, and so you can kind of see how that looks when it runs. And you could actually copy and paste and run it as well. But you can see how it automatically does all three. Okay, so just this one command is going to run through all three of those methods. Okay, and each one has a write line statement. And then I invoked it a second time with random numbers. And again, it went through all three methods. The last time I removed a method, and then you can see that it went through adding and checking to see what is larger. It did not do the product because I removed it. So the example that we looked at earlier with the three methods that don't accept any parameters and don't return anything, we could have set these up as a multicast delegate. And so this is how you would do that. So instead of having three different delegate objects, we're only going to have one. Okay, and so we create the one object and associate it with the first method. And then we add in the second and the third method. And then to run all three, we just use the delegate object. And that'll automatically run all three. So I'm going to run this so you can see how slick that works. So we did not have to create and run three different delegates. We created one delegate and ran it. So kind of to summarize, any method can be single cast to a delegate. It may not be appropriate for all methods to be multicast. And the reason is if you're using class properties and the values are changing, you may not be able to use the multicast. because it will be changing the value in every, in multiple methods, unless that is what you want. Okay. So, um, it depends on what you want it to do. But if I tried to set this up as a multicast, um, and I put addition in first and multiplication in last, okay, it would run through this and it would add the value and then it would multiply by the value. So it kind of double dips on the value. If that's what you want, that's fine. But if you did not intend for the number to be added and multiplied, then you would not want to use multicast. One thing that does make single and multicast delegates a little tricky is that you do have to look at the context in which you are using them to code them correctly. So, where is the delegate defined? Is it defined globally? Because if it is, then all of the classes and methods know about it. Or is it defined in a class? Okay, and do you need to prefix it with the class name? Are the methods static? Okay, if the methods you're associating with the delegate are static, then you don't need a class object to call them. However, if the methods are not static, then you have to create the class object and include that when you are assigning the delegate, just like we did here. Okay, so answer was our class object, and we have to use that to invoke the method. Okay, so if it was a static method, we would not need to create the class object. So that's one thing that you need to look at. Is the method static or not? This little class, you can see that we have static methods. So we don't have to create a class object to use addition or multiplication. And then is the delegate in the same class as the methods, or are they in different classes? Because that may impact how you have to prefix everything. Now, you could have a situation where methods need to be either executed by different delegates, or you can use one delegate and you can add and remove methods. And a situation where that would occur is this little shipping example where VIP customers get a discount. And if you're not a VIP, you do not get a discount. And so this little calculate discount method needs to be added in for VIPs and it needs to be removed for regular customers. So how do you handle that? Do you create two different delegates, one for VIPs and one for regular customers? Or do you have just one delegate and then choose to add or remove the calculate discount method? So that is, a coding decision that you have to make. In this example, I first created my shipping object, and then I decided to do two different delegates. I've got one for non-VIP, and for that one, I'm just adding in the shopping cart, the order price, and the order confirmation. And then I have one for a VIP where I am adding in the shopping cart, the order price, the discount, and the confirmation, all of them. And I should mention that these are executed in the order that you add them. So the order matters, okay? So here I've got three different customers. Middle one is a VIP. This handles it quite nicely because When I call process shipped, and if we look up here, let's look at our delegate, okay, calling that orders. And here is process shipped. Okay, so when I call this, I'm passing it order process, okay? Which in this case, because that's a regular customer, it is my delegate for a non-VIP. Here where I call process ship, I'm passing it order process VIP, which contains all of the methods for the VIP. And here again, I'm doing order process, which is a non-VIP, which contains these methods. So I'm telling it through the delegate which methods to run, and I'm also passing it the data that those methods need. Okay, and so here is how it works. Whoops, don't want to do that much. So this looks a lot more complicated than it is. Okay, so again, I've just got these methods up at the top. Shopping cart, order price, confirmation, those are for regular customers. All four need to be executed for VIPs. Okay, so I've got the delegate that I've declared up here, and you'll notice that it's not returning anything and it's passing order ID and customer ID. Okay. And then I've got the class, the shipped class object that I'm creating here because I need that to call the methods. And shipped is my class. Orders is my delegate. It is part of the shipped class, so I have to do shipped.orders. Order process is my object. New ship.orders. Here's the method. And again, deliver orders is my object, class object, calling the method. And then I add in the other two methods that it needs. For the VIP, I'm giving it a slightly different name. Okay. And then I'm adding all four of the methods. Okay. And then remember, delivers orders is my shipped class object. It is calling process shipped. We are passing it the delegate, okay, either order process or order process VIP that contains the methods that need to be executed. And then we are passing it the order ID and the customer ID. So we will run this. So this one is a regular customer, and you can see I've labeled the methods so you know when it's running through the different methods. And here's the VIP with the labeled methods, so you can see it is doing all three. And then we are back to a regular customer. Now, the other way to do this would be to use a single delegate instead of two. And, add and remove methods as needed. So this example shows the exact same thing, okay? But instead of two delegates, now we have one. Okay, and so order process at this time has the shopping cart, the order price, and the confirmation. It does not have the discount. Okay, so it's fine for a regular customer. But customer 2 is a VIP. So we need to add the discount in there. And these have to be run in order. So I need to remove get order confirmation because that needs to run last. Okay, and then I'm going to add in calculate discount followed by get order confirmation. Okay, and so the first two methods are still in there. Get shopping cart items and calculate order price. Those didn't need to be changed. But in order to add calculate discount and have them go in the proper order, I had to remove get order confirmation, add in the calculate discount, and then add back in get order confirmation. And that way it'll process in the correct order. And then for the last one, I had to remove calculate discount. Okay, the end result when you run this is going to be identical to the previous example. Okay, the difference is this example uses 2 delegates and this new one uses 1. Okay, but if you look at the output, you will notice the same methods are running and the same data is displayed. So those are custom delegates. Those are delegates that you create using the delegate keyword. So you create them, you instantiate them, you invoke them. C# does come with built-in generic delegates. Function and action are two of these built-in delegate types. Function can have input parameters, and you can also return data. Okay, so you will use it for methods that return a value and take 0 or more parameters. But the key here is it has to return a value. Okay, so it is built in. It has to return a value. You can have up to 16 input parameters, but you cannot use ref or out. Okay. And you can use these with anonymous methods and lambda expressions if you would like. And just as a little side note, an anonymous method is one without a name. So there's a method body, but no name. So this little example shows how to use the function delegate with a static method. So here we have a static method, so we do not need a class object. And we use the keyword func. We are telling it what the values are, the data types of the values. So we've got our input and our output value. We are defining an object name for the delegate, calculate, and we're setting that equal to the sum method. Okay. Another version of this, because I wanted to show you how to set this up using an anonymous method and also how to set it up with a lambda expression. So here is kind of the same thing. You'll notice that the delegate object name is different. And so this is an anonymous method. So we are setting that equal to delegate. This is our input. And then remember, function has to return something. Okay, so here's what we're returning. And then here we are invoking or executing. And you can see up with this example, here is where we are invoking. Now this can also be done with a lambda expression. And so we've got, again, our generic delegate func, and then we've got our object. Set that equal to, and we're setting it equal to the lambda expression. So this is similar to the anonymous method, okay, but we don't have to use a lot of the keywords. So we don't have to tell it that X and Y are delegates or integers because it's going to figure that out. Okay, and then we don't need to have the curly braces and the keyword return. It figures that out. Okay, and so then we're running it here and passing it two values. Okay, and all three of these are going to basically produce the same result. Okay, this one is associated with this method. This one is not, right? We've created our own little method here. Okay, it's anonymous because it doesn't have a name. And here, we've also kind of created our own little shortcut for a method using the lambda expression. So the only one that's actually using the sum method is the first one. So that's a function delegate. An action delegate is used for methods that have a void return data type. So they are not returning data. They can take 0 or more parameters up to 16, but they can't return anything. So this is a built-in delegate type. It cannot return a value. You can have 0 to 16 input parameters, but they cannot be ref or out. And you can use action delegates with anonymous methods and lambda expressions, just like you can use func with the anonymous method and lambda expression. So here is a very similar example, but we have a void data return type. And so you can see here that we're just writing to the console what the sum is. And the first example, our calculate delegate, is associated with the sum method. Okay, so when we invoke it here, it is going to run the sum method. The second one, we are not using the sum method. We are creating an anonymous method. So we're calling our delegate calc result. Okay, and you can see these are our input parameters, and then this is what the method is doing. So when we call it, this is what gets executed. And then the third one, we are using a lambda expression. And so again, we've got our delegate object calc result 2. Here we do not need to tell it, if we're using the lambda expression, we don't really tell it the data type because it's going to figure that out by looking at the action delegate. Okay, so all we really have to do is tell it what we want to execute, and that is console.writeLine. So when we invoke it here, this is what runs. So now we've looked at custom delegates. We've looked at some built-in delegates, and we're going to take a look at how you can use delegates with an event. Now, in a lot of the .NET frameworks, events are raised by clicking buttons or doing something like that. And so because we're looking at a console app, only for a couple more weeks, guys, then we'll get into doing some graphical things. But we're looking at a council app. And so really one of the only events that we can detect is when something is done running. So that's the event that we're going to be looking for. But in .NET, events follow what's called an observer design pattern. And so this is a software engineering pattern where an object, which is called a subject, maintains a list of dependents. These dependents are called observers. And basically it notifies them of any state changes. And that usually happens by calling one of their methods. The class who raises the event is called the publisher, and the class who receives the notification is called a subscriber. And there can be multiple subscribers to a single event. And usually a publisher is going to raise an event when some type of action occurs. So, in a web based app, it'd be clicking buttons, that type of thing. In our council apps, it's when a procedure finishes. In C#, an event is an encapsulated delegate, and it's dependent on the delegate. The delegate defines the signature for the event handler of the subscriber class. So an example will help you unravel what all of that means. It's easiest to just show you an example. So to declare an event, we declare a delegate and we declare a variable of the delegate or an object of the delegate with the event keyword. All right, so let's take a look at how this is done. We have a delegate called notify. So it's not returning anything and there are no input parameters. Okay. Then in our little class, process business logic, we have an event. And we've got public event. We're using the event keyword. And you'll notice that we have notify here. And then we have process completed. So process completed is a variable of the delegate. The delegate is notify. Process completed is the variable. Okay, so we've got our delegate and we've declared the event with a delegate variable or object. Okay, then you can see in this little class, we have a method called start process. Then we also have one called on process completed. Okay, and this is where it is checking this delegate variable or object. It's got a question mark after it, which means it can be null. If it's not null, we are going to invoke it. Okay, we're going to run it. So as long as it's null, that means it's not done. It's not complete. We aren't going to run. But once it is not null, we can go ahead and invoke it. So what is it that we are going to invoke? Okay, that comes to step 2. We have to register an event. So to register an event, we're going to create a little method that is an event handler. And so you can see I've got PBL for public business logic under or process business logic underscore process completed. Right? And then it's just going to print process completed. Okay. So this is my event handler. So when it detects that the process is completed, I want it to run this. Okay, so I've got to connect process completed with this. The way I do that is first I have to create a class object because I am dealing with a process business logic class. So I've got my PBL object. And then I take that object dot process completed, and I'm going to connect it to my event handler. Okay. So at this point, I have my delegate, I've got my event, and I have my event handler. What I'm missing is a statement that is going to trigger this whole process. So I need a class object that will call start process. That's going to be my trigger. So I've got everything else in place to handle the event. Okay, so this is the full programming example. So again, here's my delegate, connecting it to an event here. Here I'm seeing if process completed is null or not, because if it's not null, then I can go ahead and run it. And what am I going to run? I'm going to run the event handler that I have associated with process completed. And that is associated right here. And here is my trigger. I take my class object and I call start process. That is the trigger for the whole thing. So let's see this run. Okay, not very exciting, but you can see that it did go through start process because we saw process started. Then it called on process completed, which is down here. So at this point, process completed would not be null because we ran something. So it's going to invoke the handler, which is down here. Okay, and so you saw process completed. So I thought it might be fun for you to see another example. And for this example, I've got a delegate that I'm calling notify, and it is receiving a parameter. It's not returning anything. Okay, so the delegate is set up a little bit different. And so I was kind of thinking of maybe dreaming of summer and picnics. And so, you know, at picnics, they always have all these different food contests. So that is kind of my inspiration for this program. So here we've got our event, and we are calling it contest end. Okay, so we've got our delegate object or variable, contest end. Okay, and so you can see our class here is called picnic. We have a method called eating contest, and it's going to pull in the number of contestants. Okay, and then we've got a random number that we are retrieving. And basically, we are going to try to determine who is eating fastest. And we're going to be using random numbers to fill in the data. So we have a random variable. We are creating a little array using the contestants that are coming in. So each contestant is going to have their own little element there. We've set done to false. I've initialized champ at -1 because we don't have a champ yet. And the first to 100 wins. And so while they are not done, I've got my little for loop here. And so 20 is the number of contestants, although I probably should have just used contestants there. But anyway, 20 is the number of contestants. And so we're going to loop through our contestants. And as long as for that particular contestant, the value is less than 100, they are not done eating. So we add a value. Otherwise, if we have a contestant that has reached 100, we have a winner. So we will set the champ to the subscript. Each of these little index or subscript numbers represents a person that is eating. So we set that equal to the person that is eating. We set done to true. We continue. So now we are done. And then we call a little method called the winner, and we pass it the champ, okay, which is the contestant who won. Okay, and so here we've got the winner, and then we just print out, we have the winner, and we call contestant end with champ. Now, where is contestant end? Contest end is my delegate object, okay? So that is invoking the delegate. In the program is where I have my event handlers. So I have one for hot dogs and I got one for a pie contest. And we are just bringing in one integer, and that is the number, contestant number of the winner. Okay. And so first I create a class object for the picnic. And then I'm going to register the event. So first, I've got my class object dot contest end. This is my delegate. And I'm registering this little event handler, hot dog contest end. And then I trigger the event. So I call eating contest and I'm sending it 20 contestants. Okay. And then once that gets going, right, it's going to end up passing the number of the winner through here. It calls contest end. Well, right now contest end is associated with hot dog contest end. So it's going to come and run through this code. Okay. So at this point, this triggers the event and it's going to run through all the associated methods and it'll be done. So now I want to do a pie eating contest. So I'm going to subtract out the hot dog contest. So I'm removing that. And now I'm adding in the pie eating contest. Okay. And I am triggering this by passing 20 to eating contest. Okay. And so now it's going to come through here and it kind of works the same as it did before. Okay. It figures out who wins. We send the contestant to the winner. Okay. We have a winner. We pass that contestant number to contest end. Contest end is our delegate. And at this point it is now associated with the pie contest handler. So it's going to run through this. Right? Now, just so you can see how you might do this with a lambda, I remove the pie contest handler, and then I am associating a lambda expression with this because now we're going to have a cookie eating contest. So by putting the lambda in here, I don't have to create a separate method for the cookie contest. Okay. I can bring in the winner, which is an integer, right? And then I can just display who the winner is. Okay, so I'm now associating this with contest end. So when I call eating contest here, now it's going to go through all this code. It's going to pass the winner here, say we have a winner. And now when it executes or invokes contest end, it is going to run through this code. Right? And so let's go ahead and run this. And I thought this was a funner example or more fun than the previous one, just because it involves food. All right, so here we go. So for our hot dog eating competition, the winner is 10. Pie eating, it is 17. And contestant number 6 is the winner for the cookie. Now, could I make this a little more flexible? Yes, the one thing I could do is instead of hard coding that here, I could just put contestants. Okay, and then that would allow me to send different numbers in here. So we'll run it with 20 and then I'll change the numbers. Ooh, number 10, won twice. That's a hungry person. All right, so let's say we don't have as many people who want to eat hot dogs. And then let's say we have a lot more people that want to eat cookies. Okay, so you can kind of see how that works. So again, we created our delegate. Okay, we created our little event here and kind of associated it with our delegate object. Okay, and then once the eating contest is done and we have a winner, that is when we are going to run the method that is associated with our delegate, and we are passing it the winner. And the way we are associating the methods with the delegate is we're adding in the event handlers. Okay, so here we have an event handler, which is just a method. So we're adding the method. And then to do a different one, we're subtracting out the hot dog. We're adding in the pie contest. And then so you could see how to do it with a lambda, which is, a method. It's just a shorter way of doing it. We still have to subtract out the pie contest. And then we kind of defined the method here using the lambda. And so for the last one, that is what it is running. Okay, so hopefully that all makes sense. If you are confused about anything, please let me know because we are going to be working with these this week and in upcoming weeks. And you do need to understand delegates for your certification exam, which is in the 255 class.